Hi, now we are going to talk a new chapter, work, power, energy. You carry a bucket of water, move and keep it somewhere. Physically, you have done some work. Physics wise work done is zero. Central stationல போயிட்டு போர்ட்டர்கிட்ட நம்ம கொடுக்குறோம் ட்ரெயின்ல போறதுக்காக. போர்ட்டர் தலையில வச்சுட்டு போறாங்க, கையில எடுத்துட்டு போறோம். கம்பார்ட்மெண்ட்ல கொண்டு போய் வச்ச அப்புறமா பிசிக்ஸ் வைஸ் யூ ஹவ் நாட் டன் எனி ஒர்க். ஏன்னா தீட்டா இஸ் ஈக்குவல் டு 90, ஒர்க் டன் ஜீரோன்னு அவன்கிட்ட சொல்லிப்பாரு. ஓங்கி ஒரு அரை அரைஞ்சிருவோம். Purchasing a pump for your motor to take water from the sump or the well, you are using half HP, 1 HP, 2 HP and all. Why they are using horse? Horse is running fast. Cheetah also will run fast. Why you are not using cheetah power set? Hi, now we are going to talk a new chapter, work, power, energy. It's a very interesting chapter, lovable chapter, of course. One by one we will see work. So there is a basic difference between physical work and physics work. You cannot compare these two. Physical work is different. Definition of work in physics is different. Don't compare. Why, sir? We will explain. Work is said to be done means a force must be applied. Because of the force, the body should be displaced. So displacement should be along the direction of force. Then what is the work done? If it is in some other angle, what is the work done? Suppose this is the displacement of the body in which a force F is applied in this direction. The angle made between these two is theta. Then the definition says F is equal to component of force along the direction of displacement. So component of force means what, sir? Any system which is not in equilibrium position should be resolved into two components. Suppose you are projecting the body with a velocity u, horizontal direction u cos theta, vertical direction u sin theta, provided theta is along the horizontal. You take a pendulum, you are oscillating a pendulum. Center, there is a weight acting downwards, mg. When it is displaced towards the right hand side, then this mg is not in equilibrium position. So you have to resolve this into two components, mg cos theta, mg sin theta. So anywhere the system is not in equilibrium means it should be resolved without changing the original value. That we'll discuss later. So F is not in equilibrium position. You are pushing a box. Exactly theta is equal to 0, you are not pushing. Some other angle you are pushing irregularly, making an angle theta. So the definition says work done is component of force along the direction of displacement into the displacement itself. You know very well, this is Fs cos theta, that is F vector dot S vector. This is known as scalar product of two vectors. Displacement is a vector, force is a vector, but work done is a scalar. It is not depending on any direction. Work done is not depending on any direction. Okay, now three cases when theta is equal to 0. What is W? W is equal to Fs. when theta is equal to case 2, when theta is equal to 90, you know very well cos 90 is 0, so work done is 0. Here cos 0 is 1, so we have written Fs. Case 3, when theta is equal to 180, W is equal to minus Fs. We can see the examples for all the three. What examples are? Generally, most of the cases, theta will become 0 only. Theta is 0 only. That means when you push a body along the direction of displacement, the force is applied. The body is moving. So theta is 0. Theta means it is the angle between force and displacement. In this case, both are in the same direction. So theta 0. Some other irregular angle I am moving, sir. Then you apply the value for theta. Fs cos theta will give you the work done. Okay. Second case. Theta is equal to 90. Theta is equal to 90. What example we can say, sir? You carry a bucket of water, move, and keep it somewhere. Physically, you have done some work. Physics-wise, work done is 0. Why is 0, sir? Here I have done some work. You have done some work, but the displacement and the force, both are perpendicular. Central ஸ்டேஷன்ல போயிட்டு போர்ட்டர்கிட்ட நம்ம கொடுக்குறோம் ட்ரெயின்ல போறதுக்காக. போர்ட்டர் தலையில வச்சுட்டு போறாங்க, கையில எடுத்துட்டு போறோம். கம்பார்ட்மெண்ட்ல கொண்டு போய் வச்ச அப்புறமா பிசிக்ஸ் வைஸ் யூ ஹவ் நாட் டன் எனி ஒர்க். ஏன்னா தீட்டா இஸ் ஈக்குவல் டு 90, ஒர்க் டன் 0ன்னு அவன்கிட்ட சொல்லி பாரு, ஓங்கி ஒரு அரைஞ்சிருவான். அப்படின்னா என்ன அர்த்தம்? Physical work is different, physics work is different. So this is theta is equal to 90, physics wise work done is 0. Third, theta is equal to 180. When you apply a force, body should move in the opposite direction. Here most of the students will get confused with the example. They will say swimmer is an example, recoil of gun is an example, propulsion of rocket is an example for theta is equal to 180. No, wrong. All are wrong. Sir, I am throwing the ball on the wall. It is coming back. Theta is 180. No, it is not like that. Then what is that? And all Newton's third law, what you have told was these things. Propulsion of a rocket or recoil of gun or swimming, all these things. Newton's third law example. Action is equal to minus reaction. Here, why you cannot say theta is equal to 180? Because, sir, swimming means you are pushing the water in one direction. When you push the water in one direction, that direction only water is flowing. Theta 0. You are applying a force to water and you are seeing the person who is moving. These are two different objects, sir. Wrong. Newton's third law is not that one. Newton's third law, action and reaction concept, this example you can tell. But here, it is acting on the same body. There, it is acted on two different bodies. Okay, so what example we can tell, sir? Sir, in this case, suppose a person is kicking a ball, football. Another person is just stopping it. Theta 0. Kicking direction only, ball is moving. The person who is holding, he is just opposing force. That's all. You are moving in a vehicle, you are applying a brake. When you apply a brake, vehicle will not move in the backward direction. But acceleration is negative. That is called retardation. Theta is equal to 180. That's all you can tell. When you apply a force on the spring, opposite direction, there exists a restoring force. So displacement and a restoring force in opposite direction. Theta is 180. Okay, fine. Now, work done by constant force, work done by variable force. What is called constant force? What is called variable force? Generally, we can represent work done as Fs cos theta. That is Fr cos theta. R is the displacement. S is the displacement. R is the displacement. Anything according to your own convenience. So I can write here F dot dr W. Integration. Integration is nothing but a summation series. Small values you take, add everything, total value you call it as integration. 100 small values you are taking, all 100 values you add. Instead, starting point, ending point, 0 to R. Starting point, I am just starting the work. Theta is equal to 0, or theta is equal to 90, or theta is equal to 180, whatever it is. Here, theta is equal to 0 case we are discussing. So, what is the formula? Here, theta is equal to 0. Therefore, W is equal to F dr. Cos 0 is 1. 0 to R limit. W is equal to F is a constant force. Force is constant. R. Integral dr is R. 0 to R limit. Upper limit minus lower limit. Upper limit is R. Lower limit is 0. So we can tell F into R minus 0. No, sir. I will not put 0 to R. I will put Ri, initial, Rf, final. Then Ri to Rf. Then here, upper limit minus lower. Upper limit minus lower. Rf minus Ri. Final work done minus initial work done. Change in work done. You can tell. This is work done by constant force. Correct? Variable force means you can express it in graph. F cos theta versus displacement or displacement. This is component of force. Like this, sir, it is varying. F cos theta is not constant, it is varying. You take the portion A, B, C. Along the direction of x-axis displacement, along the direction of y-axis, we are writing F cos theta. So these two we are putting in a graph. Generally, area of the graph, work done is equal to integral F dot dr, that is area ABC. Any graph you take, any graph. Product of x-axis and y-axis will give you area of the graph. Product of x-axis and y-axis. Already in laws of motion chapter, with the displacement and velocity, displacement and time, we have discussed this concept. Area of the graph, if you want, means multiply x-axis value and y-axis value. That's all. How can you say this area is called work done, sir? What is x-axis, ma? Or what is y-axis? F cos theta. Multiply these two. F for cos theta. F for cos theta is nothing but work done. Correct? So this is another example. Next, power. Power is equal to rate of doing work. Already we know the word rate means whatever quantity you are putting by time. So work done by time, we call it as power. No, sir. I will write work done as force into displacement, F into dr by dt. You can write F into dr by dt, rate of change of displacement, that is velocity. If you want, you can express in vector also. Power is also a scalar. Work done is a scalar, power is a scalar, energy is a scalar. But you see, it is a vector product of two vectors, force and velocity, or it is a vector product of two vectors, work done. What is vector product of two vectors? F into dr. That is also F vector and dr vector. Displacement and force. This is power. Unit of work done is joule. Work done unit is joule. Or it is force into displacement. We can write Newton meter. Dimensional formula of work done. Force, what is force? mlt power minus 2. What is displacement? L. So I can write m L square t power minus 2. Dimensional formula of work done. Correct, Amma? Similarly, unit of power. Work done by time, joules per second or watt. What is the unit of power? Sir, horsepower they are telling. Half HP motor, 1 HP motor, we are talking even now also. We are purchasing a pump for your motor to take water from the sump or the well. You are using half HP, 1 HP, 2 HP and all. Half HP, 1 HP is more than enough for domestic supply. Agricultural paddy field, you want to take the water for a long depth, more depth. For that, you need 2 HP motor. What is that, sir? HP? HP is called horsepower. 1 horsepower is equal to 746 watts. What is that 746 watts, sir? Of course, that's not your lower class theory. Macbeth experiment they have conducted. From that, they have proved this many number of horses power is equal to 1 motor power. Then 1 horsepower is equal to that motor power by number of horses. Why they are using horse? Horse is running fast. Cheetah also will run fast. Why you are not using cheetah power, sir? More it can carry. Elephant power we can use. We cannot use. Elephant power, cheetah power, no, you cannot. Elephant power means the elephant only will move. That's all. Step by step. You can walk faster than elephant. So you cannot use. Cheetah and all we cannot use. Tamed animal only we can use, man. Because one boy asked one question in the class. Cheetah is the fastest, sir. Why not we are using cheetah? Casually he asked us for a joke, he asked, I don't know. But the concept is tamed animal only we can use. You can use cheetah. But after that, somebody should be there, no? Cheetah alone will be there. We will not be surviving. The cheetah we cannot use. For carrying loads, persons, and then going for a distant place. Olden days, they were using horses. So, horsepower, it is maintained that is equivalent now also for using motors. But SI unit of power is watt. 1 kilowatt, 1000 watts. 1 megawatt, 10 power 6 watts, 1 megawatts. You can convert horsepower also in terms of kilowatts and megawatts. Simple. This is another formula. Vector product of force and velocity is called the power. Okay.